Hi, everyone. I'm Bohdan Yurov, Senior Solution Architect from GlobalLogic, and today I'm going to present our comparison of different AWS orchestration solutions. Basically, it's EKS and ECS. The reason why this whole POC has started and why we have investigated them, continuous requests from different customers on consulting, on basic comparison, and also recently AWS has shipped FarGate support for EKS. So it was some nice feature to investigate. So let's begin with some business goals definition because this will help to guide the overall presentation. So with Amazon, you have multiple solutions to schedule your containers. It can be EKS, ECS, bare metal, like bare EC2 machines, so virtual machines. And for orchestrations, you can use different convenient tools, like with EKS, you use the Kubernetes API, with ECS, it's Amazon ECS API, and so on. Basically, you have two scheduling options here. You can use virtual machines, or you can use serverless solution. So we decided to compare them one by one, not touching the heterogeneous configs. So it's ECS and EKS on EC2 and FarGate. Also, to make this closer to some real-world scenario, we are going to compare different routing scenarios on this platform. So we will use path-based routing for accessing multiple services. We will use DNS-based routing mostly with load balancers, as well as some content-based routing just to show how this can be implemented. So once again, we will compare 4 different solutions, and we will go through pros and cons of each of them. Regarding list of technologies that we are going to use, everything that I'm going to show you is based on Amazon services. So for supportive role, we will also deploy a bunch of different solutions that are required for deployment, for management, for DNS configs, routing, and so on. I will stop on them as soon as we get closer to the demo. Let's begin with generic ECS description. ECS is Amazon Managed Service, mostly related to just running some serverless applications, but ECS also supports using virtual machines. So technically, you can also use persistent layer as well as full rich set of running applications on virtual machines. And ECS is kind of vendor lock. So going with ECS means you work with Amazon API, you only work with ECS concepts. So the only part that is not related directly to it is basically Docker and some routing scenarios. Just for you who don't know how ECS works, for it, to actually get traffic inside your cluster, as soon as someone wants to access the application, request goes to application load balancer that distributes traffic among list of services that you run inside Docker containers. Those Docker containers are targeted by ECS target groups, and target groups are related to ECS service. So service is abstraction that unifies a bunch of containers and the way that they are scheduled. With EKS, you actually have some managed Kubernetes solution. I'll stop on Kubernetes a bit later. So basically, EKS is Amazon service that allows you to manage and provision Kubernetes cluster without the need to control master nodes. It also provides you with some convenient APIs to control the cluster, to do cluster upgrades. All you need to do is just add some computing power with node groups or scaling groups, or use FarGate. That is basically the reason why we have created this POC. So just a few words on Kubernetes. The master part that is controlled by EKS is a set of services that control the overall orchestrations and can also host different components required to run applications, while working nodes is target environment that is used to actually land those applications. So master controls and working nodes are for applications to run. There are different types of applications you can run, and there are different concepts related to Kubernetes. We are not going to cover them. But basically, Kubernetes is a really rich solution that allows you to do much more than simply running container on virtual machine. So going further, the main reason, as I've stated, is FarGate, because Amazon FarGate is a service that provides you with a way to run your applications in a serverless fashion. Obviously, serverless doesn't mean that no servers are used, but you cannot see them, and they are controlled by Amazon. And basically, all you need to do is just specify amounts of compute power as well as memory. So FarGate is a tool and a service provisioned by Amazon to run your applications without the need to provision any virtual machines and without need to control them. FarGate previously was only used for ECS. Around end of the previous year, it has also shipped to EKS. So that means that you can run your pods and you can run basically almost all resources related to Kubernetes inside FarGate. It still has a bunch of limitations that I'll talk about, but basically it's something that everyone can at least investigate, because for some scenarios it might be much more convenient than EC2. So the difference is really straightforward. With EC2, you control your own structure. With EC2, you provision virtual machines. You control the operation system that you use. While Amazon provides a bunch of images to be used for workers, still you can build your own images and you can install whatever software you require, as well as also having the full set of features of the EC2. So you can use GPU accelerated nodes, you can use huge nodes or persistence layer or whatever else is supported by the EC2. FarGate is much more limited, but at least it allows to run the applications. With FarGate, you can mostly only just run them. You cannot attach the volume, and you don't have that kind of control that you have with EC2. So regarding limitations, as I've stated, FarGate on EKS is a bit limited. There are a few concepts that are not supported on EKS and FarGate at all, like you cannot use daemon sets. They actually don't make any sense with FarGate because you don't have some actual nodes. I'll show you that while technically FarGate on EKS shows list of nodes as some virtual nodes it uses to provision applications, still those are not real nodes that you control. You can also use privileged containers. So that means that most components like nginx, ingress, or some extended features for EKS and Kubernetes are not supported at all, as well as different limitations that we won't cover because for basic scaling, it doesn't really matter. So for those who haven't worked actually with EKS or ECS like at all, I just want to quickly refine a bunch of terms. So for ECS and EKS, cluster means abstraction layer that allows you to orchestrate your images. So instead of just managing a virtual machine and directly deploy to it, you deploy to the cluster, and then cluster manages the way those services are scheduled. For EKS, the minimum abstract unit for running application is pod that can contain multiple containers. For ECS, it's task. It also supports running multiple containers, but it's a bit more different from pod, as EKS provides some features that are not covered by the ECS. So EKS and ECS are two convenient tools that you can use to run your applications, but eventually, as soon as you start working with Amazon or you think about migrating from on-prem and bare metal, you need to choose one of them. As rule of thumb, I can recommend just using ECS if you don't have the need for EKS features, because it's just simpler. It means you will have some kind of vendor lock, but at the same time, deploying EKS cluster even with Amazon managing the master nodes might be more difficult for support and even for initial deployment. So per pricing, I will talk about it later when we will touch the node groups, but EKS charges you for each control plane, while ECS is technically free, but you need to understand that for both solutions, you still need to use either FarGate or EC2. So you always pay for computer resources you provision for your applications. So from the cluster itself, EKS is non-free, ECS is free, but you always pay for resource for your application. With both solutions for EKS in ECS, the same set of limit supply, I think what we should really touch is pricing, and this means much more for EKS and for ECS, because with FarGate you pay for all the resource that you provision. So let's say you have some application that requires memory, CPU, you pay for whatever you have specified in your requests. With EC2, you technically can overcommit. So you can run more containers on single node that it should support as soon as your application is not on the full load. So with EC2, you have better control over resources that you provision, and it can be cheaper, especially if you use some on-prem nodes or reserved instances. With with ECS, the flow is the following. You have the load balancer. So where's the mouse? You have the load balancer that is used to get traffic inside your cluster. Technically, you're not required to use load balancer because you can run applications that don't have any API, but still for most applications that don't apply. So you have load balancer that works with ECS service, and service uses task definition to provision tasks. So task definition is kind of set of rules on how you schedule your containers, and service use it to provision a bunch of tasks with your final containers, and then load balancer distributes traffic among those tasks. With EKS, you have multiple solutions. So let's start with FarGate and generic Amazon solution called Amazon ALB ingress. As soon as you deploy your application, it automatically creates application load balancer inside inside Amazon. So let's say you have a bunch of pods. Those pods are grouped by a specific service, and that service has some ingress resource. So application load balancer is automatically created for ingress. With Kubernetes on clouds, you have another solution, just bare load balancer. It's really comparable to the ALB ingress. That means that you simply provision load balancer for your service, but you lose many features over routing control, and usually you should prefer ingress because of it being native for Kubernetes. And technically with ingress, you can switch to other ingress controller, or even later switch the whole cloud as soon as you want to migrate. And I've seen some real life examples of companies migrating, for example, from AWS to GCP to utilize GKE and some native GKE features. And it was much simpler to just produce ingress resources from it. You can have complex routing with ELBs. I will touch them as soon as we hit the demo, because we have at least 3 scenarios, and 2 of them are fully covered by load balancer. But basically, with ELB, you can have some complex rule based on headers, based on path, or other conditions that you specify. And with different ingress solutions, you can just provision them as a bunch of annotations, just labels on the ingress inside your cluster. With ECS, it's a bit different because you provision the load balancer by yourself, but still you can have the same set of rules. Finally, for Kubernetes, there is another solution called nginx ingress controller. In general, you might have different controls provisioned for your cluster. So I'm just talking about 2 most used. And with nginx, you literally provision some nginx instance to your cluster, and ingress resources control the routing inside nginx. So as soon as you deploy a resource of this kind, as well as with ELB ingress controller, it automatically configures routing inside the nginx controller, so that all the traffic goes through it. It provisions single classic load balancer. For some use cases, this means that you can spend less because you don't need to have separate load balancer for each service. So for example, load balancer costs about $20 per month. If you have 50 services that don't have high load, that would mean $1,000 per month. With single nginx ingress controller, single load balancer, it would be just $20. Ingress is complex abstraction because technically it's another layer of load balancing, but we won't cover most of the features except routing based on path rules and headers to show that we can do content-based routing with EKS in a really simple fashion. Finally, there is so-called service mesh inside the Kubernetes. You can use different solutions. The most popular is Istio. It's not covered in this POC, but for the sake of completeness, just wanted to say that it allows even better control with virtual services, with also having egress resources, and you can have full observability of the whole traffic inside your cluster. So you can literally watch like the flow between your services. You can work with it in real time. You can see that some circuit breaker is currently working and so on. As one of the business goals that we have defined initially, we've had path-based routing. So just to show that we can have single entry point and single domain name, I've also provisioned Amazon API Gateway just to distribute traffic among those services. It's not actually the way how API Gateway is usually used, because you have full control over your list of REST resources and you control each endpoint, each API call. I'm only using them just some forward proxy. So getting closer to the demo, initially I've said we will cover 4 different use cases. So let me just quickly go through it. Starting with ECS. With ECS, you have the only solution for the load balancing. It's Amazon ELB, and it's pretty straightforward, like some native feature provided by Amazon. We also provision multiple load balancers because I will deploy at least 2 services inside every cluster. And by 2 services, I mean the demo application that I've created and some canary application just to show that we can have control over canary releases or some complex deployment scenarios, like we can use blue-green deployments or anything else. In this particular example, I'm just deploying a separate application called canary. So we'll have at least 2 load balancer per each cluster. And also with ECS, we'll have content-based routing based on the canary header. It's just part of the ELB set of rules, so it's not that complex. With EKS, we need to have some better comparison because, as I said, FarGate is a new feature, so I really wanted to test as much as possible. Unfortunately, I've hit issues with nginx ingress and some other components because of FarGate limitations. So I'm going to use Amazon ELB ingress. That means that we will have a separate load balancer per each service. And for EC2, for EKS, we will just use nginx ingress with that single classic load balancer. I can show them right inside the cluster. So I have already provisioned them. So let's start with load balancing. You see that we have 2 load balancers for the ECS clusters for EC2 and FarGate. We have some listeners defined on them, and we have 2 ECS clusters provisioned, each of them having 2 services and 4 running tasks, because for each service I deployed 2 instances. And with Amazon and ECS, it's really transparent. Like you can work with your ECS clusters right from Amazon console. You can go right to every service. You can check what's happening inside. You can jump right to logs for your services and so on, because it has native integration with CloudWatch. With EKS, it's a bit different. Like we're using native solution, we're using EKS managed clusters, but they don't have that level of control because Kubernetes is technically not Amazon product. It's covered by a Cloud Native Foundation, and they only do master control. So at least we can see what is happening inside the cluster, the status, and the computer view. We don't see any workloads, we don't see any services, but we have basic configuration. So for FarGate cluster, we have so-called FarGate profiles. They map specific Kubernetes namespace to configuration of FarGate, and that means you can define some IAM profiles, you can connect them to security groups and so on. For EC2, we won't be able to even see the nodes because for them to pop up here, we need to use node groups, and those are still really limited. For example, you cannot control taints, you cannot control basically even tags. And for this demo, I'm just provisioning some bare upscaling groups with EC2 instances. To provision this, I've used Terraform and Ansible. The reason behind that is pretty simple. I'm really comfortable with using Terraform for provisioning resources because of the declarative way it works. Ansible is only used for imperative part because Terraform is mostly used for some kind of static resources. For the sake of this demo, to deploy applications, we need to literally build some Docker image, push it to ECR, update services, test them. So I also have Ansible pipeline doing that. So the entry point is straightforward. It's just make file running Terraform scripts. And for those of you who haven't worked with Terraform, Terraform requires remote state because it handles all the changes in a three-way. It has local state, the actual code in your local repository. It has remote state, and by remote state, I mean literally some storage Terraform uses to save last configuration, just to see what has changed. And finally, the real state, the real infrastructure. So it compares it and calculates how possibly can it modify resources to change the real structure to look as we have defined in Terraform files. Sorry, Ansible is more straightforward because it works in an imperative way. We have some playbooks defined, and playbooks is basically just definition of different roles we run. And for Ansible role is combination of different tasks that we need to go through. So it's really close to just basic scripting. It partially has state, but due to imperative nature, it doesn't truly compute any difference. So for example, if you remove some resource from here, it won't be reflected on your instruction. For this demo, I'm provisioning a bunch of shared resources that are required for, I'll just quickly finish with modules and get back to questions. So for the sake of this demo, we are provisioning some shared resources, the API gateway, and I'll show you it in action. We have some shared ECR repository as intermediate storage for images that we deploy. We also have the VPC configuration because networking should be defined. And this is like a full flow demo. We can deploy it to some empty Amazon accounts. So we need to configure our subnets, private, public, and also add tags related to Kubernetes. Also, we have resource group because we always keep track of resources that we deploy. So everything is tagged, and we can apply different billing rules to them so that we control every demo. And row 3 config so that we can actually access our cluster. So just a brief glance on the row 3 config. So I have provisioned on some subdomain called tt.demogl.com, and you can see that there is a root record pointed somewhere. So I can just quickly say that somewhere is actually API gateway, and several subdomains leading to some load balancers. Okay, just quickly checking. Before we jump right to the demo, I wanted to quickly answer. So can you please make a conclusion comparison of ECS versus ECS plus FarGate versus EKS and EKS plus FarGate from cost-benefit perspective? So, I mean, this obviously should go into some kind of summary, but this was partially covered. So from cost perspective, EKS can be just a bit more costly due to the fact you pay for control plane. For many applications, that doesn't really matter. Like it's about $100 per month, but still for really small projects, this is a big deal. So I would say that FarGate in general is costlier than EC2. And if you compare ECS and EKS, it's not about cost of resources. EKS means you need to have some qualified engineer that needs to work with Kubernetes, needs to know all the resources related to it. So it might be costly simply due to the overall solution cost, not the infrastructure, but rather the EKS support costing more. So ECS is just simpler. It's possible to use service mesh Istio when using EKS plus FarGate. Yeah, I think I can quickly answer it. So probably not. I've seen some open issues on Istio, but FarGate is simply very limited. Like Istio in type of configuration deploys bunch of containers as daemon set. So the first basic feature of Istio is not supported because there are no daemon sets in FarGate. And I think this applies to many other limitations too, like permissions. Okay, so getting back to the code and demo. So we have some shared resource provisions. And for those 4 configurations, we are including 4 modules. We have some config related to it. The most interesting part is probably just pass through for VPC config. Local artifacts directory that I will show to you, because we are provisioning some resources that we need to talk to. So we have kubeconfig to access Kubernetes cluster, for example. And also we have this shared ECR repository and other things provisioned. So we need to pass through them to the final cluster. For EKS, it's a bit more complex because it also controls thread 3. Because it has DNS integration in ingress resources. And as you can see, there is just a switch, like if we are going to run on FarGate. The reason is that those modules are abstract, so you can treat those as some kind of clean functions, only having inputs and outputs, and working in idempotative way. So as soon as you run this provision, you can run it as many times as you want. And also it being clean means that everything required for provision is set in some input variables. So the same modules are used for EC2 and FarGate because they are really similar. I'll start with EKS. So EKS obviously means deploying the EKS cluster. I'm just using some community module. For EKS, you need to provision a bunch of IAM rules, configurations. You need to also apply the authentication map. I really don't want to mess with it manually, especially for the POC, so I'm just using the community module. And also, you can see that we are defining a bunch of worker groups if we are running on EC2. And for FarGate, we have FarGate profiles. I've shown them in the console inside the FarGate cluster. So you can see that we define 2 FarGate profiles for default namespace and kube system namespace, and those map to FarGate profiles in the real structure. Yeah, I'll get back to questions a bit later. So with those modules, you also need to provision some supporting resources. The only example here is the IAM role that we use for EKS to run pods inside FarGate. And we also define some access keys used by Ansible. They are only related to the way I deploy the application. For EKS to actually deploy it, as I've said, I'm using Ansible. It runs through several steps. The basic one is authentication inside the ECR. Then we deploy a bunch of components. And by components, I mean deploying the ingress. And also for FarGate, we need to modify some configuration related to core DNS and some basic stuff. And here comes just another outcome of EKS and FarGate. Like literally, if you simply provision the cluster, it won't start even in the official guideline of Amazon. You need to patch resources automatically created by the control pane. So if you use tool provided by the Amazon EKS tool, it will do it for you. But you need just for the sake of understanding how new this feature is, like they literally don't support this inside the console or through the API. So the basic cluster simply won't work with FarGate. You manually need to update configuration for some services. We use Helm to deploy applications. Helm is a package manager for Kubernetes that combines different manifests. And I can show you the manifests. They are straightforward. We just have some YAML file defining the way we run our applications, the container, bunch of environment variables, and so on. Sorry. So that's it for EKS. For ECS, it's really similar. We provision some ECS clusters. The difference that with Kubernetes, the part that creates the service and applications and the load balancer and ingress is part of the imperative pipeline. With ECS, you need to modify Amazon resources. So as I've said, as soon as you deploy, for example, your service with Amazon application load balancer ingress, it automatically creates load balancer for you. That is not true for ECS, and we need to manually create them for each service that we deploy and define those listeners and control them and so on. So this might be the only part that is simpler with EKS, because with Amazon plugin for Kubernetes, with Amazon Cloud, it just partially does it for you, configure sorting and so on. But from the perspective of later usage, ECS is simpler. We also provision some nodes, and by nodes I mean some auto-scaling group that is used to provision those virtual machines. If you go to console, I can show you that we have some auto-scaling groups provisioned for this demo. I think there might be some other garbage too, but yeah, so demo TT and demo TT ECS. So we have two scaling groups because we have EC2 on both EKS and ECS. And these results in bunch of instances up and running inside the Ireland region. And finally, to cover the ECS, to provision those services, we firstly define some stub task definition. We deploy the applications after running Terraform. That's why we need to firstly create some stub definition only to have the service. It simply won't be, you cannot create without task definition, and we use some stub task definition based on nginx. That is later updated during the deployment stage right here. So we create new task definition for the application itself, for canary release, and then update services to target that task definition. In the Amazon console, this results in you having those services right here, and you can see that task definition is like the 9th deployment of this particular one. So, which is better for just reading question, which is better for machine learning, EKS or ECS? It's possible to run machine learning models on FarGate. Well, technically, it shouldn't really matter for you. As soon as you don't use any persistence, and I don't think you use it like on EBS volumes, it should be almost the same. So with FarGate, you cannot mount local volumes. So as soon as you store all the data in some database or S3 bucket or any other cloud native solution, you're fine. I think the only big difference is the fact that with FarGate, you have a bunch of limitations. I think I've had the slide. So with FarGate, you have a limitation of amount of resources that you, okay, I won't look for it. So with FarGate, you have limitation on how many resources you can provision. So it has 3 cap on the CPU, on memory. And with EC2, you can use like ridiculously big machines with hundreds of CPUs. I'm not sure it is applied to specific machine learning case, but I can expect that you might need some specific configuration of your virtual machine, like huge amount of memory or huge amount of CPU or whatever else. So yeah, it can be different, but usually it doesn't really matter. For EKS, ECS, I don't think they have any features that should affect the way you work with machine learning. So getting back to the deployment part, for this demo, I've created some trivial Go application. It does nothing except just reading a bunch of environment variables and outputting them. It defines some endpoints, the one for liveness check or health check, and another one just outputting a bunch of information that you'll see. So for this demo, I'm using the same source folder, but I'm still building separate images. So if I go to list of applications that I deploy, I just map all those applications to a single folder, but obviously it doesn't mean that this is a single application. So it's just for simplicity. And you can see that even for the sake of this trivial POC, still we have applications not truly hard-coded, but rather a list of them that we are going to deploy. In real life, you usually don't deploy all the applications and you don't store them in a single repository and you don't have them as a single pipeline. So probably you split them and have multi-layer in structure, like some basic layer and then layer related to a specific stream or team, and then layer related to particular applications, and you continuously do deployments and you have separate repositories for them. Obviously, there is no reason to do this for the sake of POC, so I have all those configurations right here. You can see that we have some references, like literally referencing some resources from local scope, so that we don't hard-code any values. The only different part is basically environment. So we use the environment configs so that we can at least know where we land. And we also have that kind of release. It still uses the same source code, but still that's another image. And obviously, you can literally have a separate release that you are going to call canary, or like for blue-green deployments, you can have even two different versions or whatever else. So the Docker file is really straightforward. It's just building the application and putting them in Alpine image, and they land on those clusters. So those two ECS and EKS clusters. With ECS, I can show them you running right here. In the console, you can see that we have two sources in each of them, two on EC2, two on FarGate, some running tasks. It's a bit trickier with Kubernetes, but I have already connected to the clusters, so let's show me. Yeah, I'm just hoping that we'll see it right now. So this one is EC2. You can see that we have two EC2 nodes running with FarGate. With FarGate, that's some virtual nodes that you cannot access, you cannot see them. It just represents, from Kubernetes perspective, instances that are used to run your FarGate applications. And you can see that each application technically lives on separate nodes. You don't know where exactly it lands, but yeah, so it's basically somewhere in Amazon, but you can at least see that it provisions some virtual machines or uses other shared instances. And finally, for the applications, so you can see we have 4 containers running, 4 pods, but in each pod we have just single container, 2 for the application itself, 2 for canary release, and the same is true for FarGate. Here, right here. So getting back to those applications, let's start with just bare load balancers. So I have those applications open here, like they're currently responding on my requests. And while on ECS, we hit 2 different tasks, I haven't added any code that shows the task name, like the container name or host name. With EKS, it's much easier because we have it in the environment, so I'm just outlining here. You can see that I update my page and it lands on different containers. So the load balancer works perfectly. And those subdomains are related to a specific cluster that we use. If we go to the root tree, you can see that they are bound to some load balancers and one by one. So ECS, those load balancers are provisioned right by Terraform. Getting back to the module. So it's ELB right here, and all the configuration is applied to those load balancers. Yeah, these two. So you can see we have tags defined, we have listeners defined, and we have HTTPS listener as well as some certificate bound through the Amazon Certificate Manager. And for Kubernetes, it's a bit different for EC2 and FarGate. For EC2, we're using nginx ingress, so we have single load balancer for all requests. I think it's this one, right? So it just routes traffic to the load to the nginx, and then nginx, based on the host header, distributes traffic among our services. So basically, it's DNS-based routing because we use different domain names, and those domain names to map to different load balancers, and also domain name inside nginx ingress is later resolved by nginx, so you can apply some rules based on it. You can have dynamic DNS names and so on, binding some wildcard or whatever your scenario is. For FarGate, it's really close to ECS because we are using location load balancers. So you can see just one LB right here because I'm using the same set of rules. Like it's really close to what I have on ECS. The single load balancers with basically single rule. If we have canary header, hit the canary release. If not, hit the generic release. And getting back to those applications, you can see that we hit some demo application. If I modify the canary header, like I just enable it, we hit the canary release. So it's not about just changing the title. It literally hits other application. So you can see that the pod name is different, has the prefix, and so on. And finally, for routing, we have that API gateway I've been talking about. I don't really suggest using it in that way because API gateway is some feature-rich managed service. But for me, it was just the simplest solution. So I have just 4 prefixes for our 4 configurations that proxify all requests to some endpoint. I think I can see it here. Yeah, so we have this HTTP proxy that just proxifies requests to some final endpoint, and that endpoint is just the same domain you might have seen here. Yeah, I disable the canary header. So you can see we have this tt.demogl.com. It's secure because API gateway supports not only custom DNS, but also security on the API gateway level. And for the same domain name, hitting different URIs, we result in different applications running. Honestly, it passed through all the configuration. You can define which headers you pass through, but in this scenario, I'm just using all of them. So if I change the canary header, I will also land on those canary releases. And the most important part is that, as you can see in the gateway configuration, I don't have anything related to canary header. So API gateway, as soon as we hit, for example, ECS EC2 demo, just pass through the request to the ECS EC2 load balancer. And later, the load balancer itself, based on the header, lands requests on different set of containers. So it was the ECS EC2. We have them as separate services. So as soon as we hit it, we work with demo canary. Okay, that was the most basic part. I don't see any more questions for now. So let me just dive a bit more into how the configuration works. So as I've said, there is entry point running Terraform. So the flow is the following. For this POC, I've just made everything 2 steps. I first deploy the most basic infrastructure, like the clusters, the IAM, the root tree, and then I separately deploy applications. I cannot do this in a single run because between deploy infra and deploy apps, we need to configure ROS3 because I'm using DNS delegation. You can see that in ROS3, had is tt-demo.gl.com, and on demo.gl.com on the TTP subdomain, I have a NAS record pointing to this ROS3 zone. And also during deployment, we literally build the application locally and push it to the ECR right from my laptop. We also have some integration related to login. I think we can even get to the CloudWatch. It's not really that entertaining, but all the logs for all applications land on some central place that has some ridiculously high SLA from Amazon, so you can treat it as almost 100% because of the amount of reservation they do for API requests. The console itself is obviously not 100%, and we cannot have 100%, but for API that collects the logs, it's extremely high. We probably have plenty of those for groups, but at least we have those demo TT. So we have it for all the ECS, and I think we have separate one for the EKS. Also, we have log streams for pod running inside the clusters. So as you can see, it doesn't really matter where your application lands. You can have a central point, and you can process in whatever way is comfortable for you. Yeah, I think that's it for now. So feel free to ask any questions, even if you feel like they are too abstract or related to a particular technology, because yeah, if you need clarification on how, okay. So can you please recommend some public code, Terraform, or CloudFormation CDK repo with EKS and EKS plus FarGate to make a sandbox and experiment with it? So for EKS, it should be really simple. Like with EKS, I'm using this community module that simply provisions the EKS cluster. It is like full-fledged. You can just use it to provision it as whole, and they literally have some examples when running it. So it's basically just Googling Terraform, Amazon, AWS, EKS. As for FarGate, I'll be honest, it's really tricky. So with Terraform, I don't think you will have some exchange solution. You might see some new repos if someone else is investigating, but it's really new. Even this community model doesn't support FarGate yet. But you can do it just going through the generic Amazon guide. Like, I think it's partially even covered right here in the README. So talking about like Hilo strips, for EKS and FarGate, you have this EKS util that creates the cluster for you. It goes through all the steps. So it's really straightforward. For manual testing, all you need to do is just do EKS create cluster. Then there are deployment examples right in Amazon documentation, so you can deploy some guestbook application, and then you simply need to port forward that application to your laptop to see it in action. Yeah, it should be fine for at least basically testing it. For tweaking configuration, yeah, it's a bit more difficult due to EKS and FarGate being really new. So I just suggest starting with the basic guide from Amazon that they have published several months ago. Yeah, just to understand that it's not difficult. Like I'm really comfortable with Terraform because I've worked with it a lot, but the whole set of codes is really small. Like for EKS, it's just 43 lines or so. And for it to work, we just need to point it to some subnets and VPCs. And that's basically all. So I have that VPC config only because I don't want to use default VPC. For FarGate configuration, yeah, it's tricky because I don't think there are some good guides yet that will probably come in the nearest future. But still, you just define some FarGate profile. You can even create it by yourself in the EKS, like right here. So yeah, even working with these tools, it should be straightforward. like this whole POC has been created during 3 or 4 evenings. Yeah, I just suggest to check in some community models. Because yeah, I haven't seen the full demo. I mean, this whole POC was created because we didn't find some good definite sandbox. Okay, any more questions? We still have a bit of time, so while I'm waiting for some additional questions, I can show how the ingress works in this scenario. So we have this EKS module, and I have the Helm chart that is used to deploy resources inside Kubernetes. It might look a bit overwhelming, but only because it's used for 2 different ingress controllers. So you can see that nginx part is really straightforward. I just define some canary header, and depending on whenever we deploy canary release, I either mark it as canary or not. ELB, with ELB ingress, I define a bunch of JSONs that are just transparently processed by Amazon. So those rules, actions, conditions, they are configured as some target groups inside Amazon for the ELB. I'll probably wait for like 4 more minutes. So if you feel like you need more clarification on particular tooling or sources in general, feel free to ask. Yes, so while I'm waiting, just a bit of summary. Once again, EKS and FarGate is a really new solution that is not that solid and stable as EC2. Like EKS in general is almost a new technology. It has been there for not longer than a couple of years, and it doesn't support many features. It's not supported in multiple regions. Like with EKS, you cannot use some admission controllers, and basically almost everything that is related to the master control pane, they still haven't added it to the Amazon console and API. But still, we're using EKS on like dozens of our customers. Literally, we have shipped thousands and thousands of different containers on EKS, so it's stable. But with FarGate, you need to consider those limitations. You need to consider reduced amount of support and so on. So yeah, it still means you should probably try it for yourself, but keep in mind all those limitations. And ECS is something that has been created before EKS as generic way to schedule images, schedule containers inside Amazon. So it's a bit more stable, but if you require some extended features, you probably need to think about using Kubernetes and EKS. I see there's something else. So will you share this Git repository with code? The repository itself is public. I'll need to talk with the webinar manager, so we will check how we can handle it. Like, yeah, sure, the code can be shared, but we need to figure out if it's just some mail thread sending it to everyone or some event update. So, yeah, we will find out where. If you feel like you have missed something in the week, if you haven't received any notifications, you can feel free to just contact us. Maybe delivery has been lost somewhere. But yeah, we will consider sending it to everyone. And yeah, if there are no more questions summarizing, I really encourage everyone just go and check it. Like going through basic guide takes an evening. Even if you haven't worked that much with Amazon, while you can face some issues that we will need to resolve, like basically configuring IAM, VPC, security groups, still, as soon as as soon as you just follow the guide, you should be able to at least work with it. You will be able to see it with your bare eyes, and you will be able to touch the cloud, and possibly later consider implementing it in some real case. So it's 5 p.m. in Kharkiv. I think we should probably wrap up. I don't see anything new, so yeah, that's it. Thank you a lot for attending the webinar.
Dear colleagues, thank you very much for your time. Hope to see you on our next on-air webinars. Have a nice evening and bye-bye.